In this question, we're asked to find the distance between the transit and the survey pole. Now, what this is measurements by a surveyor, and basically what we have is a triangle. It's a special triangle. It is a right angle triangle. We're showing that right here. We're given this side, we're given this angle, and we're being asked to find the distance between the transit and the survey pole. Survey pole is up here, transit's down here. We're looking for this side. So we can call it X, we can call it whatever we want. But now we have to solve it. Well, we have a right angle triangle, and I'm just going to work through how I would solve this problem. So first thing I'm going to do is label the sides and the angles so that I can work with it. And I'm also going to straighten out the triangle and work with it here on the side. So we have one angle, angle T is 46.5 degrees. We have the side beside angle T, which is 110 meters. That would be the adjacent side. And we're trying to find the distance between the transit and the survey pole, which would be the hypotenuse of this triangle. So in order to do this question, we have to use a trigonometric ratio. So that's a comparison between two sides of a right angle triangle. The two sides that we know are the adjacent and the hypotenuse side. Now, from what we've discussed before, some people just know this and they can automatically do it. Other people have to use a little bit of a helper, and this word SOHCAHTOA is a little bit of a memory helper. So when you're trying to decide which trigonometric ratio you're going to use, you can use this made-up word SOHCAHTOA to help you find out which one you're going to use. So which one of the three trigonometric ratios uses both adjacent and hypotenuse? Well, it's this one, which is cosine. So we're going to use cosine in this question. So when we write it down, we're going to use the cosine from angle T, that's the angle we're looking from, and it's the adjacent over the hypotenuse side. We're going to replace everything that we can. So we know that T is 46.5, we know the adjacent side is 110, and the hypotenuse we're going to write X because that's the variable that we chose. And now we solve for X. Again, there's a couple ways you can go about doing this. You can cross multiply, or you can take the steps to multiply both sides by X and then divide both sides by cosine 46. So when you multiply both sides by X, the X's cancel out on the right hand side, and you now have it in your numerator on the left side. Because we want to find out what X equals, we now have to divide both sides by cosine of 46.5, and they'll cancel out, and you'll just be left with the X over 110 divided by the cosine of 46.5. I use a calculator to do that. I like the Desmos calculator. Just throw it in, making sure that you're in degrees. 110 divided by a cosine of 46.5 is 159.8. I'm going to round that to the nearest meter. It'd be 160 meters. And that would be the distance between the transit and the survey pole. So again, it's just like what we were doing before with the tangent ratio. We're just finding the sides and doing the math.